Hey, welcome back to Math with Patrick. Today is August 29th, and this is problem number 241 from the Daily Epsilon calendar. And we're going to solve it together today. And since today's the 29th, the answer to today's problem should be 29. And one thing I'm noticing that the calendar kind of does just for funsies is that sometimes they include the current year in the problem. And usually when they do that, the current year isn't really necessary to solve the problem. And so just to kind of prove my point, I am going to put an A right here, maybe a Y actually for year, just to say that that 2025 isn't doing anything special in this problem. We're going to divide that by 30, add 30, and then subtract the year plus 30 over 30. So hopefully this number in front of us right now is the number 29. And real quickly, I can see that it is. I know that I can distribute denominators here. So this 30 could be applied to the y first, and then this 30 second. And just so that this video isn't like 2 minutes long, I do at least want to give an example as to why this works, right? We could say do 16 over 8. Just thinking about it in terms of division, that's just the number 2. If I wanted to, for whatever reason, I could split this 16 as, say, a 4 plus a 12. So I could think of it like this. And then I do want to double check that this denominator distribution at least works for another example, just to justify that I'm allowed to do it in another example. So here, I'm distributing that 8 to both the 4 and the 12 and keeping the plus sign the same. And I just wanted to double check if this strategy is okay. I can reduce these fractions. 4/8 is just 1/2. 12/8 is just 3/2. And then I know that if I add 1/2 to 3/2, I'm doing a picture model right here. Here's 1, 2, and then 3/2, where this is, one whole would just be one of these rectangles. I know that I could just stick this half right here, and then I'm left with 2 wholes, which is the same 2 that we had from before. So this step does make sense. I am allowed to split denominators. It doesn't change the value of what I got in the end. And honestly, that 30 actually from the problem statement wasn't really that important either. I'm convinced that the only reason why this needs to be a 30 is that it's 1 more than our answer. So I could even just do x plus 1 right here. And this problem that they wrote could have been for any day of the year, as long as, say, it's the 5th, you just need to put a 6 here and here. So that's why I'm also including an x plus 1, because this problem, there's nothing really special about the numbers, honestly. Here, I'm just going to solve for x, and hopefully I'll show that x is 29. So just for kicks, all these 30s are now all going to be x plus 1s. So let me just get those all there. Then I do have y over x plus 1 at the start, and then plus x plus 1. Here I can see that this fraction and this fraction cancel each other out. And then, I almost made a mistake. See this minus sign right here? It's subtracting this whole entire fraction. And so if I do split the denominator, I actually do need to kind of think about this fraction still being kind of contained with each other. And so if I did want to release those parentheses, this plus would need to be a minus. So glad I didn't actually forget that part. Well, I did, and then I realized that I wouldn't get 29 for today unless I fixed something. So anyways, these two fractions cancel. This fraction right here, x plus 1 over x plus 1, is just the number 1. I mean, unless x were, say, -1, then we get an undefined fraction. But it's never really going to be the case in this calendar that the date is the negative first. So this still holds true. where we do end up with that x like I wanted. So like I was saying, this number right here, the only reason why it's 30 is just so we got 29 as our answer. This very well could have been any number, and we would have just gotten one less as the date. So there's my answer. I circled the X that's supposed to represent the 29 for the 29th today. And we're all done. Nothing really special. It was just an arithmetic problem that I made more complicated. So anyways, thanks for watching, and I'll see you tomorrow. Bye.